Hello. Today we're going to be learning about mechanisms and simple machines. This is found in 1.1.1. Simple machines you may have learned about in earlier grades, but we are going to be talking about the 6 simple machines in much greater detail. The 6 simple machines are lever, wheel and axle, pulley, inclined plane, wedge, and screw. But before we go into the details of each one of those, what we got to talk about is mechanical advantage. Simple machines help us either increase or decrease the amount of force that required to do a specific task. Now, some mechanical advantages are going to deal with the ratio of the forces, how much you put into a system compared to how much. So, for an example, going up a ramp. It requires a lot more effort to lift a fridge from the ground up than it does just to push it up the ramp. So the ramp has a mechanical advantage. But with that comes a disadvantage, and that is distance traveled. Lifting a fridge straight up from the ground up doesn't require a lot of distance, but going on the ramp requires a larger distance. The calculation of the ratio allows us to calculate how fast or how much distance you are required or how much force you need in a specific mechanism. So here's the example of that inclined plane. In this example, it has a ratio of 4:1. What does that tell us? Well, it tells us the magnitude of the force. So let's make this box weigh 4 pounds. If I were to lift it directly straight up off the ground, its force would be, if you pull it straight up, it would be weigh 4 pounds. But pushing it up the ramp, it should weigh 4 times as less, or as if it weighed only 1 pound. But distance also goes the opposite. Let's say it goes up a foot. Well, then it's going to go up the ramp, it's going to take 4 times as long, or 4 feet. Now, work is another equation. Work is force times distance, and they have to be in parallel. That's what this symbol represents. We will see when force times distance in the perpendicular, but that will be for later. This is in parallel, so force has to be applied in the same direction as it's moving. This is work. The work here, 4 pounds times the 1 foot going up, has to equal the 1 pound moving the 4 feet distance. They are the same. Now, mechanical advantages deals with the number 1. 1 is its magic number. If a mechanical advantage is greater than 1, it means it requires less force to do that compared to its resistance, or 4 times as long to do it. But if you have a mechanical advantage less than 1, it means it's going to require more force to do that compared to its resistance. But it's going to do it in less distance. Mechanical advantages never can be equal to 0 or a negative number, because that would mean it went a negative distance or had 0 force or 0 distance. It didn't move. That doesn't make sense. Now, we're going to talk about ideal mechanical advantage and actual mechanical advantage. Ideal mechanical advantage deals with no friction. It's the ideal, theory-based, and it deals with the distance. We know how tall that ramp was. We know how long the hypotenuse of that ramp is, so we can calculate it. It's the distance effort over the resistance. That would give us our ideal mechanical advantage. The actual mechanical advantage, though, is taking friction into account. You have to get it. It's called inquiry-based calculations. Or you have to physically do it. You have to put a force probe on it. So I put in a force probe, and I did not get 1 pound out, but I got a little bit more. So again, this is your actual force. Notice, though, IMA has the distance effort over resistance. AMA is resistance over effort. They're backwards of each other. So make sure you put your correct units in the right places. You will be able to use the equation on equation charts, but make sure you keep track of which one's your effort, that's what you are putting in, and resistance. What is the object trying to resist you doing? Now, what can we look at this? What has a greater mechanical advantage? Well, lots of things have mechanical advantage. Crowbars requires less force to open and pry a box open. Maybe it's a pair of scissors or pliers. Those have mechanical advantages greater than 1. On the other hand, what has mechanical advantage less than 1? Weightlifting equipment. These plates don't weigh actually 20 or 10 to 20 pounds. They're only a few pounds. So when you lift 100 pounds on these weight machines, they don't have 100 pounds worth of steel there. What they're doing is only having about 20 pounds worth of steel and have a disadvantage of 1/4 or 1/5. Thus, you're pulling 100 pounds, but you're only picking up maybe 20 pounds. Compound machines are then when you combine two mechanical systems together, so two simple machines. So in this example, the wheel and axle and another wheel and axle, and all you do is just multiply the mechanical advantages together. Again, if you have any questions, come and ask your teacher. Thank you and have a great day.